guys, today we're going to review a concept you may have learned before. It's called Punnett Squares, and it's about figuring out what are the chances of children from this union having a certain trait. So let's see, we'll just title this Punnett Squares. I know this is a review, so I'm going to keep it short. So there's a few vocabulary words that we just need to hash out really quick. Let's see, the word probability means what is the percent chance? And when we're working with Punnett squares for just one trait, you're going to have the percent chance be either 25%, 50%, 75, or 100. So if it's 1 in 4 boxes, that will be a 25% chance. If there are 2 out of the 4 boxes, it'll be 50%. 3 out of the 4 boxes will be 75%. And then 4 out of 4 would be 100%. So when we ask what is the probability, we're looking for a percent. Okay, and then let's see the word homozygous. Homo means the same. Zygous means a zygote. A zygote is an egg plus a sperm. So a sperm plus an egg equals a zygote. This was what you were at the very, very beginning of your life. So homozygous means purebred. Pure breed. Anything with the word pure in it means that it's homozygous. So it can either be homozygous dominant, which means it's capital. Both of its alleles are the same. That means it's pure. It's purely one thing. Or it could be homozygous recessive. So that means it's lowercase. Or if it's not a pure breed, it's a mix, we call this heterozygous. And that would be 1 dominant allele and 1 recessive allele. So you're going to be reading these word problems that tell you what the genotype of a living thing is. So let's just remember, what is a genotype? This will be the genes which lead to phenotype, which is physical appearance. All right, let's go down here. Let's set up our first Punnett square question. Here it is. Okay. What is the probability of a homozygous recessive for hair color baby to be created from a heterozygous mom and a homozygous recessive dad? Okay. So I've got to figure out what my parents are. Mom is heterozygous, so we'll just use a random letter. The letter does not matter. It's the numbers that matter from these problems. Okay, so she's heterozygous. And the dad is homozygous recessive. Those will always be given to you or will be able to be figured out. So let's see what the question was. What is the probability of a homozygous recessive for hair color baby to be created from a heterozygous mom and a homozygous recessive dad? All right. So I draw my Punnett square. A Punnett square is always a 2x2 box like this. I have 4 boxes in there. So the top is usually where you put the female, but you'll get the same answer if the eggs are over here or if the eggs are up here. And the sperm usually go on the side. And remember from the meiosis letter, you only have 1 allele per gamete or egg or sperm. So for mom, I separate these two because one will go to one egg, the other will go to another egg. This is called the law of segregation. They separate when they make eggs. So I'll put a capital A here and a lowercase a there. And for dad, his sperm will always be lowercase a because he's homozygous recessive. All right, and then you just bring the boxes together to figure out how to fill it in. So this one will have these two that come together. So that will be capital A, lowercase a. Always write capital first. Bring these two together. Capital, lowercase. Bring these two together. And bring these two together. All right, so it looks like I have a 50-50. I have a 50% chance of being recessive and a 50% chance of being heterozygous. So I have my numbers here, but I wanted to make sure I actually answer the question. So the question is, what is the probability of a homozygous recessive baby? All right, how many homozygous recessive boxes do I have? Double lowercase. 2 out of 4 of my boxes are homozygous recessive, so my answer is a 50% chance. Okay, now what I want you guys to do, I want you to practice this with 10 questions. So you're going to do your 10 answers down here. When you're done with this, I want you to take a picture of these Punnett Square notes and put it in your Google Drive. Okay, so there will be 10 practice questions. So I'm going to put those 10 practice questions on the screen. And then you can pause it and then you'll have it there. I'll also put it in your Google Drive as well. So, you know what? Let's do the first one together. You can go ahead and pause it if you've got the hang of it or you're like, oh yeah, I remember this. All right, Punnett Squares practice problem. Problem number 1. I'm gonna split screen it. Sorry for the delay. Let's go here. Let's go here. All right, problem number 1 right here. And it goes over right here. A heterozygous, capital T, lowercase t plant is crossed with another heterozygous plant. What is the percentage of offspring that will be short? I'll have to define. Short is recessive. It will always be defined for you. Okay, so I do my Punnett square. Doesn't matter if I put mom or dad on the side for mom and the other side for dad. It doesn't matter. You get the same answer. Both parents are heterozygous. So I do my Punnett square. These two letters come together to make the first box always. You bring them in. What's on the side? What's on the top? What's on the side? What's on the top? Remember, capital always goes first. What's on the side? What's on the top? You bring it in there. So go back to the question, what percent will be short? Short is recessive. The only way to express a recessive trait is to have 2 alleles that are recessive, because remember, when you have one dominant trait, it overshadows the recessive trait. So I have a 1 in 4 chance or a 25% chance of having a short offspring. All right, let's do question 2 together, and then you guys can work on your own. I'll do 2 down here. Okay, I'm going now from here over to my question. A heterozygote round seeded plant is crossed with a homozygous round seeded plant. What percentage of the offspring will be homozygous? So I'm going to cross my given genotypes. I have capital, lowercase, capital, capital. What's on the side? What's on the top? Bring it together. Capital first. What's on the side? What's on the top? Side, top. Side, top. Refer to my question. What percentage of the offspring will be homozygous dominant? 1, 2. 2 out of 4 equals 50%.